students, you are on to Dr. OJ's tutorial class. In this video, we shall be talking about elementary trigonometry. Don't forget to click on the notification button so that each time I upload a video, you'll be duly notified. Thank you. Now let's start with measurement of angle. We start with measurement of angle. Measurement of angle. How do we measure angles in trigonometry? Now, let's say given a line OP, which rotates from a position OX, to some other position, OP, then the angle POX is said to be positive, if the sense of rotation is anti-clockwise. And negative if the sense of rotation is clockwise. So these are the two senses of rotation that an angle can be subjected to. Now let's give a diagrammatic sketch for further explanation on what we meant by sense of rotation being clockwise and being anti-clockwise. Okay? Now, let's look at this. Let's say this is line OX, let's say this OX there, and we have OP that has rotated, towards this direction. So let's assume we have it this way. Okay? Yes. So this is OP now. This is an angle. This angle is going to be positive. This angle is going to be positive because it is anti-clockwise. Because the measurement is made anti-clockwise. And what do we mean by anti-clockwise? Normally, if you have a clock, this is 12, this is 6, this is what? This is 3, this is 9, and so on. The hands of the clock comes this way, go this way. It rotates this. This is clockwise movement. This is anti-clockwise movement, and this is something that is against the movement of the hand of the clock. So since this is moving from 0 now, let's say this is a 0 degree, it goes from here, from this level, this way. So we have 115 degree. We assume that is 115 degree. So this angle POX here is going to be what? Positive angle, because it is measured anti-clockwise. Now, if we have this, let's look at another one. If we have this, let's look at figure 2, something like this. Okay, this is 0 degree, and the measurement is taken from this level. Let's say here. So let's call this OP as well. We can use anything anyway, but it's an example. The OP is not constant. You can write OR, you can write O anything. Okay. Now, since this is moving this way, it moves towards it moves in line with the hand of the clock. So if this is 49 degree, then we can say that suppose this is OX, POX here is going to be minus 49 degree, because the movement of the hands here is clockwise. It's a clockwise direction. You can see this is the arrow moving clockwise. So generally, one angles of rotation is subject to the sense at which the hands moves. Okay. Now, angles are measured in degrees or radians. Angles are measured in degree or in radians. Now, one revolution, that is one complete revolution. One complete revolution is 360 degree. Okay. Now, how do we now show the difference between these angle in degrees and angles measured in radians? Now, we have 2 pi radians is equals to 360 degree, because pi in radians is equals to 180 degree. Okay, so we multiply 2 by 180, you get so that is it. From here you have pi will be what? 360 degree all over 2. Okay, so now 1 radian 360 over 2 is 180. Okay, so 1 radian now will be equal to, from here now, if pi is equals to 180 degree, or pi in radian, let's do it this way so that you understand it better. This pi is in radian, so if you want to get 1 now, pi is measured in radian, is equals to 180 degree. So 1 radian now, 1 radian will be equals to 180 degree all over this pi. Okay, that is that about that. And so if you divide your pi, you take your pi as 3.142. If you divide this by 3.142, you are going to have 57.289 degree. Now, how do you convert this to degrees and minutes? Now, originally you have the whole number to be what? 57 degree. Now, what you are left with here is 0.289. Okay, multiplying that 0.289 by 60, it gives you 17 point something. So you take the whole number from 17 point whatever it gives you, and you write 57 degree 17 minutes. Okay, now that is that about that. We have been able to see now the conversion from 1 radian to degree. That is, 1 radian now is equals to what? 180 degree all over pi. Now let's look at how to convert from degree to radian. How to convert from degree to radian. Okay, now how to convert from degree. 1 degree now is equals to pi all over 180 radians. So take note of all this conversion, because we are going to use them later. Now let's look at example. You can see that degree and radians are just inverse of the other one. Okay, you can see if 1 radian is equals to 180 over pi. So if you want to find degree now, if you multiply this one, you have pi in radian equals to 180 degree. So to get 1 degree now, 1 degree will now be pi in radian over 180. That's how we got this. It's very simple. It's very simple. Now, express the following angles. Express the following angles in degrees and minutes. Let's write them. Let's say express the following angles in let's say nearest degrees, put nearest here, degrees and minutes. Okay, now the first one, 2.1 radians. 2.1 radians. The second one is pi all over 12 radians. Okay, now this is straightforward. Fine. Solution. Now, if you say that, we could see here that this one is already in radians. We want to convert it to degree. So, how many radians do we have that is equal to a particular value in degree? We know that 1 radian is equal to 180 degree all over pi. So 2.1 radians now will be equal to 2.1 multiplied by, because 1 radian is equal to what? 180 over pi. This is what we have here. So 2.1 radians is not what? 2.1 times 180 degree all over pi. If 1 radian is equal to 180 degree all over pi, 2.1 of it will be 2.1 times. It's just like if one orange costs 30 naira, 3 of it will cost 19 naira. That's 3 times 30. Okay, so you have what? Don't forget your pi here is 3.142. So by the time you divide that, you're going to have 120.316 degree. So how do we now convert to minutes? Okay, now originally the whole number here is 120. You write that degree. Now if you remove 120 from 120.316 degree, you'll be left with 0.316 degree. So multiply 0.316 degree by 60. So eventually you have 19 point something. So now write 19 minutes. 19 minutes. You take the whole number there. Now the next one. The next one. Let's look at the next one. The next question. Let's look at the next question. Let's look at the next question. Right. Now the next question says we should convert pi over 12 radians. Fine. So the next question, pi all over 12 radians. We want to convert it to degrees. So we already know that since 1 radian equals to 180 all over pi. So pi over 12 radian will just what? 180 all over pi multiplied by pi over 12. Okay? Because 1 radian is equals to 180 all over pi. So pi over 12 radian will just 180 all over pi multiplied by, if one of it is 180 over pi, pi over 12 of it will be this. So pi will cancel pi. So if you divide 180 by 12, you're going to have 15 degrees. Okay. Now let's look at example 2. We are through with that. We have been able to convert from radian now to degree. Now let's see how we convert from degree to radian. Express the following. Express the following in radians. Express the following in radians. We have 1 A, that's 37 degree, and 2B, this is the second one, that is minus 143 degree. Now, how do we express this in radian? Fine. Now, let's write the solution up. Let's write the solution here. Now, the solution to this, don't forget that conversion. If you are moving from degree to radian, you see, 1 degree is equals to what? Pi all over 180. Okay? So, now 37 degree will now be, then 37 degree will be 37 multiplied by pi all over 180. Okay? So, by the time you multiply out, don't forget, our conversion is in what? Radians now. By the time you multiply out, you have what? 0.6458 radians. 0.6458 radians. So you do the same thing for the second one. You can attempt the second one yourself and get back to me to your comments. I want to know what you get as the second answer. So that is that about that. That is that about that. So I don't want the video to be too long. We are going to continue from here in the next video. Stay blessed.